In this class, now I am going to explain you angular bisectors from straight lines. You know students, angular bisector is also one kind of locus which you have studied in your schooling and also in the locus chapter in the 11th standard. Now let us consider two intersecting line equations like this. Let us say equation of this line be a1x plus b1y plus c1 which is equal to 0, and this one a2x plus b2y plus c2 equal to 0. These are the equations of two intersecting lines. Now we would have to find equations of angular bisectors for these two line equations. So you know students, see, this is one pair of opposite angles and this is one more pair of opposite angles. Unless they intersect 90 degrees to each other, so one pair of opposite angles are acute angles and one more pair is obtuse angles. You know this. So whenever they intersect 90 degrees to each other, these four angles will be 90, 90, 90, 90. But unless they intersect 90 degrees to each other, one pair is acute angles, one more pair is obtuse angles. So here this is the angular bisector. This is the angular bisector. What is the speciality of this angular bisector? Which is equally inclined with these two lines. This is equally inclined with this line as well as this line. Equally inclined means which divides this angle into two equal halves. Suppose if it is 60 degrees, then this will be 30, this will be 30. Like if it is theta, then this will be also theta. So this angular bisector divides this angle into two equal halves. So which is equally inclined with the two given lines. Even these two lines are also equally inclined with this angular bisector. But locus definition is, so we define in the locus like this: group of points which are all moving equidistant from two given lines. Okay, so this is an angle. For this angle, this is one ray, this is one more ray. So this group of points are moving equidistant from two rays of this angle. So suppose if you take a point over here P, so which maintains same distance from this ray as well as this ray. Okay students, so suppose if you measure this distance is d1 and this one will be d2, both will be equal. d1 is equal to d2. So suppose if you take this P as x1 comma y1, then measure this distance from P to this line. This line equation is given as a1x plus b1y plus c1 equal to 0. Now we have taken this point coordinates as x1, y1. Now measure this distance. You know how to measure the perpendicular distance from this point to this line. a1 x1 plus b1 y1 plus c1 by root of a1 square plus b1 square. Here put modulus symbol. So which is equal to, so measure this distance, mod of a2 x1 plus b2 y1 plus c2 by root of a2 square plus b2 square. You know students, so this is a locus point. Actually P can be taken anywhere. So this is a fixed point which I have taken as x1, y1. But okay, so in the locus applications, so at the end of the solution we replace this x1 y1 by xy, because this point need not be here, it can be taken anywhere on this line. Hence replace this x1 y1 by xy at the end of the solution. And see, here both sides modulus symbol is there. So whenever you remove the modulus symbol on both sides, you would have to take here plus or minus, you know that. See here, a1, I am replacing x1 by x2. a1x plus b1y plus c1 by root of a1 square plus b1 square, which is equal to plus or minus a2x plus b2y plus c2 whole by root of a2 square plus b2 square. Now when you take plus, you will get one equation. If you take minus here, you will get one more equation on simplification. So you will get two angular bisector equations. One is this one and one more is this one. Okay students? So you get two angular bisector equations. So here this may be acute angle and this may be obtuse angle. Hence it is acute angle bisector, this is obtuse angle bisector. But which one is acute angle bisector, which one is obtuse angle bisector? So I tell you how to find acute angle bisector and obtuse angle bisector. But you will get two angular bisectors. Okay? I hope you have understood this. Right. Now let us see one small application. See, two line equations are given as 3x plus 4y minus 3, which is equal to 0, and one more is 4x plus 3y plus 5 equal to 0. Two line equations are given and asking us to find whose angular bisector equations. Whose angular bisector equations. Okay students, so how do you find? So see here, 3x plus 4y minus 3 whole by root of 3 square plus 4 square, which is equal to, so here what you have to write? Plus or minus 4x plus 3y plus 5 whole by root 4 square plus 3 square. Now let us go for simplification. Here this is going to be 5, this is going to be 5, both of them cancel. Now 3x plus 4y minus 3, which is equal to, so once you prefer plus, if you prefer plus here, 4x plus 3y plus 5. Now transfer all of them to the right side so that you will get 0. X when it goes to the right side minus 5 plus 8 you will get. This is one equation. Now equate minus. On equating minus you get 3x plus 4y minus 3. When you treat this as a minus, all signs will change. You know that. 4x minus 3y minus 5. Now simplify. So bring all of them to the left side so that you get here 7x. So here it is going to be 7y. Now when it comes to the left side, plus 2, which is equal to 0. Now you got one more angular bisector equation. So like this you have to find two angular bisector equations. Okay students, and observe that angle between the angular bisectors is always 90. Angle between the angular bisectors is always 90. Remember that point. These angular bisectors are equal inclined with two given line equations, and even these two given lines are also equal inclined with angular bisectors of those two lines. Over these two angular bisectors 90 degrees to each other and which are equal inclined with two given lines. So this angle equal to this, hence it is equal inclined with these two. and this angle equal to this. Hence this is equal inclined with these two. Vice versa. Angular bisectors are equal inclined with the two given lines, and the two given lines are equal inclined with angular bisectors. And what your point you have to remember here, angle between the angular bisectors is always 90 degrees, mutually perpendicular. Angular bisectors are always intersecting 90 degrees to each other. So this is the point of concurrency of the given lines and angular bisectors. Now let us go to the models based on this angular bisectors. So in that, the first one is find the acute angle bisector and find the obtuse angle bisector. So you may ask me, sir, what is meant by acute angle bisector, what is meant by obtuse angle bisector? See, unless they intersect like this, unless they intersect 90 degrees to each other, compulsory. So one pair of angles will be acute, one pair of angles will be obtuse. So if it is acute angle, and this will be acute angular bisector. If it is obtuse, then this will be obtuse angle bisector. Then how you have to evaluate which is acute angle, which is obtuse angle bisector. So this is a rough diagram. Okay, just for the sake of explanation, I have taken the diagram like that. But exact solution we require. How to find? Okay, find the acute angle bisector of two given line equations. So this question will be given like this. How do we find? See students, suppose if it is acute angle bisector. So this is making equal angles with this line as well as this line, no? So let us consider the slope of this angular bisector is m. And slope of these two lines be m1, m2. So theta is the angle between angular bisector and the first line. Theta is the angle bisector, angle between the angular bisector and the second line. Okay students, now measure this angle. How do you measure? Tan theta is equal to, so you know students, m minus m1 by 1 plus m1. And go to this. So tan theta is equal to, so m minus m2 by 1 plus m2. So if this theta value is lying between 0 to 1, this tan theta value, if this tan theta value is lying from 0 to 1, then it is an acute angle bisector. You know students, if it is acute angle, which means that 0 to 90. If you divide 0 to 90 angle into two equal parts, so then that angle will be, each angle will be smaller than 45. Acute angle means 0 to 90. So complete angle 0 to 90. So divide this one into two equal halves, so that each one will be smaller than 45. So tan is an increasing function in the interval minus 90 to plus 90. So 0 to 90 also it is strictly increases. Hence, okay, tan 45 1 you know. Then if the angle is 0 to 45, so tan of 0 to 45 will be 0 to 1 only. 0 to 1. Hence, if this tan theta value is 0 to 1, then you can say that angular bisector is an acute angle bisector. Okay students, so this is the reason behind it. Suppose after applying this tan theta, so you may get more than 1. If it is more than 1, then that will be obtuse angle bisector. This bisector is said to be obtuse angle bisector. So if it is obtuse means how much angle is this? More than 90, less than 180. If you divide into two equal halves, then each one gets more than 45. If tan of more than 45 is more than 1 you will get. Hence, whenever you find tan of this angle, if it is more than 1, then that bisector is said to be obtuse angle bisector. If it is 0 to 1, acute angle bisector. Okay, instead of doing like this, so there is some procedure how to identify acute angle bisector, how to identify obtuse angle bisector. Now I explain you that procedure. Okay students, actually in the concept we think like this, but while going for application part, so this procedure may be somewhat difficult. So you better to remember that algorithm, how to identify acute angle bisector, how to find obtuse angle bisector. Now let us see the procedure. Okay students, in the step 1, you have to make C1 is positive, C2 is positive. Make C1, C2 both are positive. We made it. How to make positive, you know. Actually, if this equation contains C1 and C2 as positive, it is well and good. Sometimes here they may give you negative. In such case, you would have to make positive. How you can make? By multiplying both sides with minus. Okay students, here minus is given. Multiply both sides with minus so that you can make positive. Like that you have to make C1, C2 positive. If it is given as positive, well and good. If not, make it positive. And go to the step 2. In the step 2, you have to prepare A1, A2 plus B1, B2. So, A1, B1, A2, B2 collect from the two given line equations and prepare this value. If it is suppose negative, actually what are the angular bisectors after making C1, C2 positive? So here find whose angular bisector, A1x plus B1y plus C1 by root of A1 square plus B1 square, and which is equal to plus or minus A2x plus B2y plus C2 whole by root of A2 square plus B2 square. Make C1, C2 positive and prepare this. Otherwise this step write here itself. A1x plus, this is first step, A1x plus B1y plus C1 by root of A1 square plus B1 square, which is equal to plus or minus A2x plus B2y plus C2 whole by root of A2 square plus B2 square. Now in the step 2, what do you do? So you have to prepare A1, A2 plus B1, B2 students. So if it is negative, this may be negative or positive. Suppose if it is negative, students, so here this plus sign indicates acute angle bisector. On equating plus you get one bisector, no? That will be acute angle bisector. When it is acute angle bisector, whenever this is negative. And if it is negative, this minus indicates obtuse angle bisector. Obtuse angle bisector. I hope you have understood this. Okay. But here need not be negative, no, always. It may be positive. A1, A2 plus B1, B2, it may be positive. If it is positive, students, so here this plus represents obtuse angle. Reverse to this. Obtuse angle bisector. So this minus indicates acute angle bisector. Very easy, no students? Like this you have to identify which is acute angle bisector, which is obtuse angle bisector. Because exact diagram you cannot furnish on the paper while doing the applications. So that this is the way to identify which is acute angle bisector, which is obtuse angle bisector. Hope you have understood this. Now let us go to one more model. What is the angular bisector which contains the origin? Find the angular bisector which contains the origin. You may ask me, sir, what is the meaning of containing origin? See, this is a coordinate system, 2D coordinate system, in which I have drawn these two lines, given two lines. Okay, so this is line 1, whose equation is a1x plus b1y plus c1 equal to 0, and this is a2x plus b2y plus c2 equal to 0. Now, due to these two lines, this plane divides into 4 parts. So let it be 1, 2, 3, 4. This plane divides into 4 parts, like 1, 2, 3, 4. So in which part origin is belonging? In the third part. So here, if you draw the angular bisector, you get one angular bisector for these two lines like this, and you get one more angular bisector like this. Okay, but which is acute angle bisector, which is obtuse angle bisector, we cannot say. But we want an angular bisector in which origin is lying. So here, in this part origin is lying, no? So in this part, which angular bisector is moving? This one. So you would have to find this equation. That may be an acute angle bisector, obtuse angle bisector, we don't want. But we want an angular bisector in which origin is lying. Okay, students? I hope you have understood this. Yes, find an angular bisector in which origin is lying. So for this, students, very easy. Just to make C1, C2 positive. After making C1, C2 positive, so just equate that plus a1x plus b1y plus c1 by root a1 square plus b1 square, which is equal to plus or minus, no? Just equate plus a2x plus b2y plus c2 whole by root of a2 square plus b2 square. On equating plus, you get one angular bisector, no? So that will be our required angular bisector in which origin is lying. First, what you have to do, whether C1, C2 is positive or not, you have to check. If it is positive, then find this. If it is not positive, first make sure that C1, C2 positive. Afterwards, equate this plus. This plus indicates our required angular bisector in which origin is lying. Okay, students? Right. Next, one more model. Okay? So, find an angular bisector in which a point is containing. A point A whose coordinates are x1 comma y1 and two line equations will be given. Same like this here. These are the two line equations. So this line equation is a1x plus b1y plus c1 equal to 0. This line equation is a2x plus b2y plus c2 equal to 0. Now there is a one point A, x1 comma y1. So in this part, here this angular bisector is moving, no? So this you would have to find. In the previous one also. So that origin need not be on angular bisector. It may be or may not be. But in that region, whichever angular bisector is moving, that you would have to find. Here also this point need not be an angular bisector. So this in this portion, this point is belonging. So due to these two lines, so this plane divided into 4 parts, 1, 2, 3, 4. So in which portion this point is there? In this portion. In this portion, which angular bisector is moving? This. This you would have to find. Okay. Now see how to find this angular bisector, I tell you. Okay, students. First, here you would have to find this S11, S22. S11. Which means that this point directly you have to substitute in the given equation. No need to make C1, C2 positive. Okay, not required to make C1, C2 positive. That may be positive or negative. Okay, however it may be. Just simply prepare S11 means A1 x1 plus B1 y1 plus C1. And next S22. So A2 x1 plus B2 y1 plus C2. both you prepared. If both gets same sign, both gets same sign. Same sign means both may be positive or both may be negative. Both may be positive, both may be negative. If both are positive or both are negative means which gets the same sign. Which gets the same sign means, see here, a1x plus b1y plus c1 by root a1 square plus b1 square, which is equal to plus a2x plus b2y plus c2 whole by root of a2 square plus b2 square. So here plus or minus, once we take plus, once we take minus, na? So on equating this plus, then you get our required by angular bisector in which this point belonging. When S11, S22 both are same sign means both may be positive, both may be negative. In such case, this plus indicates an angular bisector in which A is containing. So if you get opposite sign, one is positive, one is negative. If it is positive, it is negative. If it is negative, it is positive. Opposite sign if you get, so you have to equate minus. That minus indicates our required angular bisector in which this point is containing. Okay students, I hope you have understood this. And the last point in the conceptual, see students, A1, C1, C2 and A1, A2 plus B1, B2. Find this value. If it is negative, then you get an angular bisector, that is acute angular bisector, and in which origin is lying. Find this expression value. If it is smaller than 0 means negative, then you get an angular bisector, no? So that is acute angular bisector in which origin is lying. But when you have to do this, okay students, when you have to do this, after making C1, C2 positive and find this value. If it is negative, then okay, we get two angular bisectors, no? So in which, okay, if it is negative, you get an angular bisector in which origin is lying, and that is an acute angular bisector. So you may get this is positive. Positive. In such case, so you get one angular bisector, that is obtuse angular bisector in which origin is lying. Okay students, I hope you have understood this. Okay, so sometimes this kind of question also can be expected. Find an angular bisector, okay, which is acute and in which origin is lying. Means you have to, okay, test this condition. So if it is negative, then you get an angular bisector in which origin is lying. If it is positive, you get an angular bisector, that is obtuse angular bisector in which origin is lying. I hope you have understood. Now let us see a few applications based on this angular bisectors concept. See these students. Yes, two line equations are given like this: 4x plus 3y minus 6 equal to 0, and other one 5x plus 12y plus 9 which is equal to 0. These are the two given line equations, and the first question is find the angular bisector of the obtuse angle between them. Means you have to find obtuse angle bisector for this. Obtuse angle bisector for this, there are 3 questions are generated, 4 questions are generated. Find obtuse angle bisector, acute angle bisector, and find the bisector in which origin is lying, and find the bisector in which 1, 2 contains. 4 questions are generated. So 2 line equations are given. First, find acute angle bisector, obtuse angle bisector. Shall we find? So first make C1, C2 as positive. C1, C2 positive. Here negative given. Make it positive. How do you make positive? By multiplying both sides with minus. So that you will get minus 4x minus 3y plus 6 which is equal to 0. And here 5x plus 12y plus 9 which is equal to 0. We made. Next, find A1, A2, B1, B2. So A1 is minus 4, A2 is 5, B2 is minus 3, B1, B2 is 12. So minus 20 minus 36, you got negative. Whenever it is negative, I said to you, okay, so that in the beginning, that plus indicates acute angle bisector, minus indicates obtuse angle bisector. We want obtuse angle bisector. Obtuse angle bisector, how do you get? So here minus 4x minus 3y plus 6 whole by. So here a1 square plus b1 square which becomes 5. So here it is, students. So obtuse we want. Obtuse means minus. So 5x plus 12y plus 9 whole by root 5 square. So here it is going to be 25. Here it is going to be 169. You will get root a2 square plus b2 square. So you know, take cross multiplication and go for simplification. So that you will get an bisector, that is an obtuse angle bisector, because you got a1, a2, b1, b2 is negative. Whenever this expression is negative, this minus indicates, I said to you, obtuse angle bisector. So in the second question, find acute angle bisector. Acute angle bisector means here you would have to put plus. Simplify, here it gets 5, here it gets 13. Take cross multiplication and simplify. You will get one line equation, that is acute angle bisector. We answer to the second question. What is third question? Find an angular bisector in which origin is lying. Origin is lying means what did I say? I said to you C1, C2 make as C1, C2 positive. I made C1, C2 positive. Okay, you got like this. Then plus indicates bisector in which origin is lying. So in the previous one, see here, this minus 4x minus 3y plus 6 by 5. So which is equal to plus 5x plus 12y plus 9 by root a2 square plus b2 square which is equal to 13. So you get one bisector. Okay students. So that is our required bisector in which origin is lying. Okay students. So actually that is acute angle bisector. So in the acute angle bisector origin is lying. Okay students. See, otherwise you can verify this one also. C1, C2, A1, A2 plus B1, B2. The last I said to you this to verify this. Yeah, 6 into 9, 54. So you got this one is A1, A2, B1, B2, negative you got here. So it is smaller than, means negative. Negative into positive which becomes negative. Smaller than 0. So this result you got negative. Negative into positive, negative. Hence, so that is an angular bisector in which origin is lying. Okay students, this is the answer to the third question. Now let us go to the fourth question. What is fourth question? Find angular bisector which containing a point 1, 2. 1, 2. So what did I say? You would have to prepare S11. S11 means simply this 1, 2 you have to substitute in the given line equation in the left side. So this is S1. Okay, this is S for the second line. So these are the two given line equations. So one point is given. You have to prepare S11 means this 1 and 2 must be substituted in the place of X and Y in the left side portion of the given line. So 4 into 1 plus 3 into 6 minus 6. How much is this? 4 plus 18 minus 6. So 16 you will get. Now find S22. Substitute this value here. 5, 12 to the 24 plus 9. So you got a positive value. Okay. So 38 you got. 38 only, no? Yeah, both are positive. Both are positive means I said to you to equate plus. See here. 4x plus 3y minus 6. Here no need to make C1, C2 positive, students. Okay. So here you get 5 now. So for this, so 5x plus 12y plus 9 by 13. So here plus, I did not write. Okay, here plus indicates a bisector in which this 1 comma 2 is belonging. Okay students, what is the last question? Find an angular bisector in which 1 comma 2 is lying means. So I said to you S11 and S22. I said to you to prepare these two. If both gets the same sign, then here plus indicates a required angular bisector in which that point 1 comma 2 is lying. Okay students. So this is the angular bisectors concept from the straight line. So in this, what did I explain you? How to find angular bisectors of two given intersecting lines. That is first model of question. So those angular bisectors may be acute angle bisectors or may be obtuse angle bisectors. So sometimes which one is acute angle bisector, which one is obtuse angle bisector, obtuse angle bisector, they will ask us. So then how to identify which one is acute angle bisector, which one is obtuse angle bisector, I said to you. Next, what is next model of question? Find an angular bisector in which origin is belonging. So we covered that model. And the last model, find an angular bisector in which a point belonging, like 1 comma 2. In the last we have discussed. Okay students. So this is the angular bisector concept and applications which you help you in your IIT mains and advanced or other competitive engineering competitive exams, students. Thank you one and all. I am requesting you to subscribe, like and share my channel so that my classes reaches to many people. Thank you. I hope you have understood this class. Thank you one and all.